I continue on topic 18 in this video, and you can see derivative rules here. So far we did derivative using first principle, okay, using that limit. If I want to repeat it here, I can say, do I have a space here? Yes. Okay, so I can say it is f prime x equal limit f of x plus h minus f of x divided by h goes to 0. That's derivative using first principle, or delta method. Instead of h, I can use other symbols, but I recommend use h. Now I want to show you some rules, and then you can use those rules to find the derivative faster. That's perfect. So if I know this lesson, then I can do it faster. Okay, so here the first rule: if I have a constant function, the derivative is 0. Okay, can I prove that? Okay, so I go here and prove it here. Okay, if I have a constant function, I can prove it. How can I prove it? I use the formula limit f of x plus h minus f of x divided by h goes to 0. Okay, so what is f of x plus h? When I have a constant function, whatever x I use, the result is the same. So it is c minus c divided by h goes to 0. So I have exactly 0 over h, that h approaches to 0, and we know h is not 0. So it's 0 over a number, very small, but still the answer is 0. Okay? Oh, yes, I can see. So I use this rule. When I have derivative of a constant function, the derivative is 0. How about cx? Oh, okay, if I have cx, let's do it here. Okay, cx, limit f x plus h minus f of x divided by that h goes to 0. So it is limit c x plus h minus c x divided by h goes to 0. Okay, in this case is 0 over 0 when I substitute h equals 0, but I have to make it clear, right? Okay, so I do limit cx plus ch minus cx over h. So you can see I can cancel this and this. So it is limit this over this, h goes to 0, this and this cancel, and the result is c. Okay, so derivative of cx is c then. Derivative of c is 0, which is a constant number, but then I have cx, it's c. I can do similarly to prove this. Okay, if I have x power n, the derivative is n multiple x power reduce 1, n minus 1. So x squared is 2x, x cubed is 3x squared. Okay, how about if I have cx power n? If you have cx power n, or if you have c multiple any function, the derivative is c multiple derivative of the function. Okay, so you just multiply it with c. Just multiply it with c. Okay, so yeah, derivative of, so if I have yes, that part is the first part, and this is this one, and then if I have fx equal, or I can say y equal, so if I have y equal c of fx, y prime is derivative is c multiple f prime x. So if I have coefficient, I just multiple. Okay, so if I have a constant number, derivative is 0, and I can prove it using first principle. If I have cx, derivative is c. If I have x power n, derivative is nx power n minus 1. You can use these rules, but remember, if I say I want you to use first principle or delta method, you have to go by the formula, which is the limit. Otherwise, use these formulas. Use all of these rules. If I have plus, derivative of fx plus gx is derivative of first plus derivative of second. If I have minus, it works. Okay? How about multiplication? How about division? No, it doesn't work for multiplication and division. It doesn't. So, what should I do then? In lesson 20 and lesson 21, we are going to see that. Multiplication and division. What is the derivative of multiplication of function and derivative of function? Okay? I will see. So, let's start here. Y is 8, y is pi. What is y prime? Y is a constant number. Y prime is 0. Y prime is 0 because y, both of them are constant number. Oh, okay. Continue. How about this? Okay, x power 7. Y prime is 7x power n minus 1, which is 6. 1 second. Okay. 7 minus 1, which is 7x power 6. How about that? Okay, I told you if I have c multiple, I just carry c or just to the next level. Okay, so y prime is 5.4 multiple 3x squared. I can do it step by step. 3 minus 1. Then it is 5.4 multiple 3x squared, which is 16.2 multiple x squared. Okay? How about here? Oh, okay. That, here I didn't say n. Here I didn't say what should be for n. Positive, negative, fraction, I didn't say. So any n, any number, positive, negative, fraction, all of them work. Oh, okay. So what is y prime here? Y prime is minus 5 x power minus 5 minus 1, which is minus 5 x power minus 6, which is minus 5 x power 6 in the denominator. Okay? So, if I have x power 5, it goes to 5x power 4. But when I have negative, it goes to minus 6. Makes sense because it's negative. I reduce 1, the magnitude of the number is larger. Okay? Sometimes I see a student, they say it is equal this. No, 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 no. Minus 5 is minus 5 unit. Okay? Which is 5 unit before 0 to the left of 0. You don't touch that. The only thing you touch is the one with negative exponent. That's it. Oh, how about here? Oh, I told you, derivative of division, I cannot say y prime is derivative of this divided by derivative of that. No, no. I told you, you are going to see division and multiplication in lesson 20 and 21. So what should I do now? Oh, okay. Remember, this is x power minus 2. You can bring it up and change the exponent to negative. Okay? We need it because we have formula here. Oh, okay. Y prime is minus 2x power minus 2 minus 1, which is minus 2x power minus 3, which is minus 2 over x power 3. Okay? How about this one? How about this one? Doesn't matter. Here I have 3 over 2. That's exactly like just like a coefficient. Okay, so it is 3 over 2. You don't touch that part. That's a number. Okay, x power minus 2. Remember, that's y. Sometimes a student, they stop here because they think they found y prime. No, still you are in y. Okay, so what is y prime then? Y prime is 3 over 2. See, you carry, okay? This multiple minus 2 multiple x power minus 2 minus 1, which is, okay, which is 3 over 2 multiple minus 2 multiple x power that, okay, simplify here, okay, which is this and this cancel. Maybe I say simplify, and also I say use show in a positive exponent. Oh, okay, so that's minus 3. You don't touch it. Okay, sometimes a student, they write it's equal 1 over 3 this. No, 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 wrong. Minus 3 is not equal this. Okay, no, I saw this mistake before. I don't want you to make it. Minus 3 is 3 units to the left of 0. 1 over 3 is not even 1. It's 1 divided by 3. So they are not like each other. No, no, no. Okay, so continue. How about here? How about fraction? Can I have fraction in the power? Yes. Oh, okay, so it is y prime is, step by step, y prime is 7.5 multiple 1 over 3 multiple x power 1 over 3 minus 1, step by step, which is 7.5 divided by 3 x power minus 2 over 3, which is 2.5 okay, 2.5 divided by x power 2 over 3. Oops. If I want to show with positive exponent, which is 2.5 over this. Okay, so far so good. How about that? Oh, okay, so this is y equal minus 2x power 4 over 5. I know when I have root, it is fraction. Okay, so 5th root of x power 4 is x power 4 over 5. Oh, okay, so what is y prime then? Y prime is, oops. So 1 second. Okay, so yes, okay, yeah. Y prime is minus 2 multiple 4 over 5. Oops, that's multiple. Then you think it is, did I make that mistake there? No. Okay, so this, I make bracket. Okay, so this x power 4 over 5 minus 1, which is minus 2. Okay, so that's minus 8 over 5 x power 4 over 5 minus 5 over 5 minus 1 over 5, which is minus 8 over 5 x power that, which is minus 8 over 5 5th root of x. Okay, so far so good. Okay, so let me check if I didn't make that mistake. So just instead of just bracket, I use multiplication, which looks like x and then confuse you. No, not here and not here. So as far as I see, so no. Okay, perfect. Yeah. Oh yes, here. Okay, so derivative of summation and subtraction. Summation, subtraction. Both of them, okay, derivative goes through. Okay, so y prime is derivative, okay, derivative of this, step by step. So I want to show you a step by step. Derivative of first, plus derivative of second, which is 2x plus 3, 1 by 1. Okay, how about that? Y prime is derivative of this, okay. So it's derivative of first, multiple that, sorry, minus that plus that, okay. Derivative plus and minus, you can say derivative of first plus derivative of second minus derivative of third, but this rule doesn't work for multiplication and division. I will show you in topic 20 and 21. Oh, okay, so this is 5 derivative of that. Here I am showing a step by step. So first derivative of that, then this, and then 2, okay, which is 5 times 3x squared minus 6 times 2x plus 2. That's 15x squared minus 12x plus 2. Okay? Yeah. How about this? Oh, okay, so y prime is derivative of the other side. I want to show you a step by step. Which is derivative of first plus derivative of second minus derivative of third minus derivative of the fourth one, this one and this one, which is 0 plus 2 minus 3x squared, sorry, I need that, minus 3 multiple derivative of this, minus 5 multiple derivative of this, minus 8 multiple derivative of this, and plus 9 multiple derivative of that, which is 2 minus 3 multiple 2x minus 5 multiple 3x squared minus 8 multiple 4x cubed plus 9 multiple 5x power 4. Okay, so now I simplified. Here I am showing you all step by step. Okay, so derivative of left equal derivative of right, then I do derivative 1 by 1, then I just have the coefficient out and derivative of the next part, okay, and then I find the answer and then I simplify. So it is 2 minus 6x minus 15x squared minus 32 minus 32x cubed plus 45x power 4. Okay, so yes, how about this one? How about this one here? Yeah, okay, so just let me check something here. Okay, so yeah, how about this? Oh, okay, so it is derivative of left is derivative of right also derivative of 1 by 1 because it's plus and minus, okay. Then you would say, okay, I don't know derivative of division, you still didn't teach me. I would say, okay, but you know you can write this, you can write this, you can write this one, you can write this, and this one, okay. So here this is minus 1x power minus 1 minus 1. Here it is 3x power, okay, sorry, 3 Okay, okay, I can do it one by one, so just step by step, I mean. Okay, so 3 multiple derivative of this plus 2 multiple derivative of this minus 5 over 3 x power 5 over 3 minus 1 and plus 0. Okay, step by step. So here, this is minus x power minus 2, yes, plus 3 minus 2 x power minus 3 plus 2 multiple minus 3 x power minus 4 minus 5 over 3 x power 5 over 3 minus 5 over 5, which is minus okay, 5 over 3, sorry, minus 3 over 3, which is 2 over 3. Yes, 2 over 3. Yes, and plus 0 here. Okay, I don't need to write that. Okay, so derivative of left is derivative of right. Then I do one by one. Okay, then I say, okay, I cannot do division, so I bring everything up and I change the sign. Root, I make it fraction in the third line. In the fourth line, I am bringing coefficient out, and then I'm finding the derivative. Okay, now simplified. Okay, so it is this. Maybe I tell you I want to see everything with positive exponent. Minus 6 this, minus 6 this, and this one. Okay, so derivative of left is derivative of right. Derivative goes through plus and minus. Okay, then I change it to to fraction as exponent or negative exponent because I want to use my rule. Okay, what is my rule? My rule is derivative of this is n x power n minus 1. I'm using that. Okay, so maybe I can write it here that I'm using this. So derivative of this is n x n minus 1. Okay, so that's for, let me see, that's for this part. Okay, and then I am simplifying it. Okay, so just to simplify, so yes, okay, no, it is this one. Sorry, it's I'm using it for the red one. Okay, here I'm showing you a step by step. Okay, so sometimes you can skip. So for example, okay, for example, right away you can go to for example second line, because we know, okay, derivative of left is derivative of right. Okay, then I just say plus and minus, so I go through derivative of first plus derivative of second. Okay, maybe you can go from, for example, to fourth line. Okay, so do you know what I mean? So then I don't know what is the derivative of division, so I bring everything up. I change to negative exponent. I have root. I change it to fraction for the fourth one, which is 5 over 3. Okay, and then I use the rule, green rule here, in order to do the red line. Okay, and then I am simplifying and I'm showing everything with positive exponent and nothing with fraction exponent. So I use roots. Okay. So the next one, what is derivative of this here? You would say, okay, is it derivative of first multiple derivative of second? No, doesn't work that way. Okay, so if I have f of x multiple gx, derivative is not derivative of first multiple derivative of second. If I have f of x divided by g of x, derivative, it is not derivative of first, it's not divided by derivative of second. No, it's not. Okay, So what should I do then? Oh, I can expand. Yes, right now that I don't know topic 20 and 21, I can expand. Okay, so what is y? Y is x squared, okay, minus 3x plus 2x minus 6, which is x squared minus x minus 6. What is y prime then? Y prime is derivative of the other side, derivative of first minus derivative of second minus derivative of third, which is 2x minus 1. Okay, show me a step by step. So it's that derivative of first, oops, so it's derivative of first. Okay, so I can do a step by step. It's derivative of right side, then it is derivative of first minus derivative of that minus derivative of that, which is 2x minus 1 minus 0. That one is minus 0, so done. Okay, so because that's 6, so derivative of a constant number is 0. Okay, how about here? Oh, here I can use Pascal. Okay, so it is y equal 4x squared plus 12x plus 9. Y prime is derivative of the other side, then derivative 1 by 1, then this multiple that, oops, that's 0, which is 4 times 2x plus 12, which is 8x plus 12. Okay, that's the derivative. So how about this here? Okay, I give you a function and then I say what is derivative at this point. Okay, what is the derivative at this point? So you can find the answer. How? Okay, you find the derivative and then substitute that point. Oh, okay, so derivative is 2.75 x squared minus 5.02x. Oops. Okay, derivative, which is derivative of first minus derivative of second okay, which is this which is 2.75 times 2x minus that, okay, which is 2.75. Okay, so 2.75, yeah, okay, so it's 5.5 times x minus that. Okay, so then it says substitute. Okay, so find that number here. Okay, so it is, let me see, yeah, okay, it is this one. Okay, so f prime at this point, it's the point is 3.36. okay, so the answer is, maybe here that I have to substitute the number, I can show it this way. Okay, so the answer is, so I can keep that here. Okay, so then I can say, okay, so what is f prime at that? So f prime is, f prime x is 2.75 multiple 2 multiple, what was the number? 3.36 minus that. Okay, 2 here is exact number because that's a power for 2. That power comes there as a formula. That's exact. Okay, so here I can tell you find the answer. That's done. You can use your calculator, find the answer. If I tell you the answer is approximate, I want you to round it. How do you round here? Okay, 3 significant digit, 3 significant digit. This is exact because comes from the power, that's power 2, comes beside. Okay, so I don't consider, so this is 3 significant digit. Then I use my calculator to find the answer. 2.75 multiple 2 multiple 3.36. Yes? Yes, that's 18.48, which means if I want 3 significant digit, I have 1 decimal place. And here I have 2 decimal place, so I round to 1 decimal place. Why decimal place? Because I have subtraction. So, red mass, I do multiplication first and then subtraction. In multiplication, I have to round to the least significant digit. So I do it. Then I want to do subtraction. I ask myself, in subtraction, I round to the least decimal place. How many decimal place I have when I go to this one? I use my calculator to see. But remember, you do not round it. No, you use the same number. The answer is 13.46. You want 1 decimal place, which is 13.5. Okay, remember, if I say the answer is, so the number is approximate. If I say these numbers are approximate, I have to tell you these are approximate. This and this and this are approximate. Okay, otherwise no, I just leave the answer as what I see, 13.46. Okay, how about this example? Find the slope of tangent line to this curve where x equal to. Okay, do you remember a slope of tangent line? That's the derivative. So far we used to do it by the limit, by delta method, by first principle. But right now I know that's the derivative. I can find the derivative. Oh, okay. Okay, so I can say, I can type here. Okay, so let me see if I, okay, so home, I'm not sure what's the reason I cannot type it here. Okay, so 1 second. I can do that, and yes, okay. So, the slope of the tangent to the tangent line to the curve to the curve y equal x squared minus 2 at x equal to is I can type it this is y prime at 2. Oh, okay, I need to find derivative, right? I need to find derivative, and then that's it. I just substitute 2. That's a slope of tangent line. Okay? Oh, okay, perfect. So, y is x squared minus 2. Y prime is x squared. Okay, 1 second. X squared minus 2 derivative, which is derivative of first minus derivative of second, which is 2x minus 0. Okay? Oh, okay, y prime is 2x. So y prime at 2 is 2 times 2, which is 4. That's a slope of tangent line for this curve, okay, to this curve at this point. Okay? So you would say a slope of tangent line to this curve at this point is equal 4. Then we remember those formula, but then we can talk about this formula here. We didn't, so we removed topic sine and cosine here, which was topic, we didn't do it 11, 12, 13. Okay, so we don't talk about these. But derivative of exponential function, exponent, okay, e power x is e power x. So that's interesting. A derivative doesn't change. Derivative of ln is 1 over x. Okay, so these are all, these two also, and also sine and cosine and trig functions, they can be proved by the first principle, by that limit. We don't do it. We just accept here. Okay? So we are done by this lesson. For the next video, I do topic 20 and 21 and the rest of the lesson. So the videos are ready. Okay? Thank you so much. Bye.